Hi, my name is Sergio Chavez and I am studying mechanical engineering at CETIS Universidad. For this tutorial called Parasolid-Solid Example, we are going to learn steps that can be used to create a VREP solid. Then create a finite element model, analyze the model and post-process the result from its analysis. This is the representation of the final piece. First of all, we have to create a new database called tension fitting. Now we are going to create the geometry for the tension fitting. We have to go to geometry, set action as create, object as surface, and method as x, y, z. Now enter phi, 2, and 0 for vector coordinate list, and enter 0, 0, 0 for origin coordinates list, and apply it. In this step, we're going to copy 2 points at opposite corners. Set the action as transform, object as point, and method as translate. Enter 0.5, 0, and 0 for translation vector, and select the top left corner point and apply it. Then enter 0.50 for translation vector and apply and select the bottom right corner and apply it. To create a curve by connecting the two translate points and breaking the surface with a curve, set action as create, object as curve, and method as point. Click on one of the points from translation as the starting point and the other one as the ending point. Then we're going to break the surface and delete the upper portion of the original surface. Set action as edit, object as surface, and method as break. First of all, turn auto execute off and select the rectangular surface for the surface list and the curve for the break curve list and apply it. And finally, we're going to delete the upper surface. Set action as delete, object as surface, and click on the triangular surface for the surface list and apply it. We are going to create a parasolid by extruding the surface. Set action as create, object as solid, and method as extrude. Select the TED meshable solid icon. Enter 002 for the translation vector and select the surface Now we are going to edit a solid using the shell method. Select action as edit, object as solid, and method as shell. Enter 0.25 for thickness and turn off auto execute, and select the three faces of the solid and apply it. We'll do some fillets on the inner edge of the solid. Set action as edit, solid as object, and edge blend as method. Select the constant radius icon and enter 0.25 for constant radius. Select edge of solid icon, turn auto execute off, and select the 5 edge of the solid inside and apply it. In this step, we're going to create a house for the tension fitting. Set action as create, object as solid, and method as primitive. Select the cylinder icon and enter 2 for the height and 0.25 for the radius. Enter -1, 1.25, and 1 for the base center point, and curve 0.1 for the axis list, and apply it. Then set action as edit, object as solid, and method as boolean. Select the subtract icon, select the tension fitting for the 30 solid, and select the cylinder for the subtracting solid. Now we're going to create the points where the 3 bottom holes will be placed. Click wireframe icon, set action as transform, object as point, and method as translate. Enter 0, 0, minus 0.5 for translation vector, and select the point at the base edge of the fillet and apply it. Now for the first point, enter minus 0.7500 for translation vector. Select the new point and apply it. For the last 2 points, enter minus 1.500 for translation vector and enter 2 for repeat count and select the newest point and apply it. Then to create cylinders using points as base centers, and then create holes by subtracting them from the solid. Set action as create, object as solid, and method as primitive. Select the cylinder icon and enter -1 for height and 0.125 for radius, and select the 3 bottom points for base center point list. Enter chord 0.2 for axis list and apply it. To finish the holes, set action as edit, object as solid, and method as boolean. Select the subtract icon and select target solid as solid 1 and select the 3 cylinders for subtracting solid and apply it. Now we're going to create a cylinder to imprint tension fitting. First of all, we have to create a point in the center of the large hole. For this, set action as create, object as point, and method as arc center. Select the large hole edge and apply it. Then set action as create, object as solid, and method as primitive. Select the cylinder icon and enter 1 for height and point 371 for radius. Click on point in the center of the large hole and enter chord point 1 for axis and click apply. Now to imprint the solid, set action as edit, object as solid, and method as imprint. Select the tension fitting for the solid list and select the cylinder for the solid to imprint. And to delete the cylinder, set action as delete and object as solid and select the cylinder and apply it. Now we are going to create a TED mesh for the tension fitting. Set action as create, object as mesh, and type as solid. Make sure that TED mesh, and TED 10 are all selected and apply it. In this step, we are going to create the loads and constraints. Set action as create, object as total loads, and type as element uniform. Enter force as the new set name and click input data. Enter minus 5000 for load and click OK. Click select application region. Select the vertical solid face created by imprinting at a larger hole and click add. Click OK and apply it. To create the constraints at the base hole, set action as create, object as displacement, and type as nodal. Enter fixed as new set name, click input data, enter 000 for translation, and click OK. Select application region and click on the select geometry entities. Select the surface or face icon and select all the three cylinders faces of the three holes at the base and click add, OK, and apply it. To create the material properties for the model, set action as create, object isotropic, and method as manual input. Enter aluminum for material name, click input properties. Enter 10E6 for elastic models and 0.3 for Gaussian ratio. Click OK and apply it. Then to create the 3D element properties for the tension fitting, set action as create, object as 3D, and type as solid. Enter 3D text for properties set name, click input properties and click matprop name icon. Select the aluminum from select material. Click OK and click add application region and select the entire solid by drawing a box around it and click add and apply it. Now we're going to run the analysis. Set action as analysis, object as enter model, and method as full run. Click at solution type and make sure linear static is selected. OK, and apply it. Attach the XDB file and access to the results. Now set action as create and object as deformation. Select displacement and transitional from select deformation result and apply it. Thank you for watching this video. I hope you like it. Don't forget to leave your likes and your comment.